Hello everyone. Our today's problem is a deep problem. So the problem is a famous one. So this is similar to best time to buy and sell stocks too. So if you have solved that, it is well and good. If you have not, we will see. We'll understand this problem in this video. So let me tell you how we will go forward. So first of all, we will understand the problem, then we will see a recursive solution, and then we will try to convert that recursive into DP solution, and in the last we will see the code. So what the problem is saying, you are given an array prices where prices of I is the price of a given stock on the ith day. So for a particular stock, prices are like this, like it is going like it is 1 on the first day, then it is going high 3 on the second day. So like this the prices are fluctuating, right? And another fee variable is given, that is nothing but a transaction fee. What transaction means is, like you if you have buy something and then you have sell something, so that is called one transaction. So for that you need to give this amount of money every time for every transaction. So you have to find the maximum profit you can achieve. So in this case, I bought at 1, like in price 1, and then I'm selling it in price 8, so that is profit of 7. And I have to give transaction fee, so 7 minus 2, that is 5, that I will be getting. Then I'm buying in 4 and selling in 9, that is profit of 5, and but I have to give transaction fee, so again 5 minus 2, so that is 3. So 5 plus 3, 8 is the profit that we are getting, so I'm returning 8. So let's see how we can approach this problem. So in the problem, they are saying we have to return the maximum profit. So I have told in the previous DP problem also, whenever in the problem they are saying all the possible, like they are saying to explore all the possibilities, like they are saying find like give all of the paths, right? If they are saying find maximum of something, minimum of something, so in these kind of problems you will like generally you use recursion. So this is a like kind of trick. So how we will see the recursion, let's see that. So recursive is what you are trying to focus on all the possible all the possible solutions, or all the possibilities rather. So for exploring all the possibilities, and out of which you will give maximum, so you need to first see what are all the possibilities. So in the problem itself they are saying you can either buy or either you can sell something, sell the stocks, right? So buying is what, like if I'm on this day, like either you can buy and either you can sell on a particular day. Let's say this is the time of buying, like you are saying like if I'm on this index, so like to sell, like before selling you need to buy something. So if you are on zeroth index you cannot sell, first you need to buy. So what are possibilities I can see here, like this is the zeroth index, first day, either I can buy it, like if I want to buy, and I can say, or I can say I don't want to buy on this day, I will buy on any other day. So either you can buy or you can skip this day. So these are the two possibilities at the time of buying. So at the time of selling also the same thing. Like if I bought this on in price 1 and I come to this, so you have buy now and now you have to sell. So these are the states, two states, buy and sell. So if you have not buy, you will buy, will go to this, and if you buy, then you will go to sell. So in sell you are like if I'm here, so what two possibilities we can see, like either I can sell it in either I can sell it in price 3, so I will get profit of 2. Like like I have to give transaction fee, but that we will do later. So either I can sell it here, or either I can skip this, like I can go and I will sell it here. So again, two possibilities. I will sell or I will not. That is up to me. I will skip and sell on any other day. So these four possibilities is what I am seeing. So how this function will be looking, this recursive function, index we will pass, and with this I will pass this by. This by is what? This by will have like two values. Like if this is a time of buying, I will indicate that with 1. If this is a time of selling, I will indicate that with 0. Because at particular index you need to know already like what I need to do on this index, because either you will be buying and either you will be selling, so you need to tell explicitly. So if this is the this is starting of the function, so what I will pass from the main function 0th index, because you will start from first day. So this is a day 1, you cannot sell because you have not bought any. So you have to pass 1. By 1 is what you will be buying on day 1, right? So this is what this is how the recursive function will look like. And what will be the time complexity for this? So the time complexity will be order of 2n by 2 power n, because you are exploring two possibilities for every index. And what will that space complexity? That will be order of n by order of n for recursive stack space. So this is the time complexity for recursive one. So let's see how we can convert this recursive solution to a memoization solution. So before seeing that, let's understand why memoization will work, right? So so I am telling you this this recursive solution like this will not get accepted because the time complexity is very high, so I need to reduce this. So let's see where I can reduce this in memoization. So this is order of 2 power n. Why 2 power n? Power of 2 power of n, because every time, like for every index you are asking, I can buy or I cannot buy, like I can buy or I can sell. That is like these two possibilities you are you are seeing every time, like for every index. Like if this is the time of buying, then you are asking either buy or not buy. If this is selling, either sell or not sell. So these two possibilities, like not buy and sell, like these two one that I am talking about. So this 2 power n is actually like you are like when you will be seeing like if you draw recursive tree, so in that you will be seeing like you are actually solving the already problem solving again and again. Like for example, if you don't buy here, you will buy here, like, right? And if you buy here, let's suppose, so you can like what I mean is in this you are solving the already solved problems again and again, so that's why it is getting like high time complexity. So how you can solve that, we will use a dp table. So in dp table what we will doing, we will like what will be the size of dp table? That is your states that are keep changing, so that is nothing but your index and by. So index what is the limit for that? That is n, like the size of index. Like index can go from 0 to n, so n I will pass. So n into what? Into 2, because by state can be 0 or can be 1. So according to these two changing parameters, I will make my DP table. And when I will make my DP table, so this will be like almost similar to recursive, but before solving before solving any sub problem, I will ask if this problem is already solved, so that I need not to solve it again. So in that way, I will decrease my time complexity. So this will decrease to n crossed 2. Why n crossed 2? Because this dp of size that only, like for these many calls only I will be solving. So like code I will be showing on, do not get like right. So this is like next we'll be seeing tabulation. So tabulation is what like for this time complexity is okay for memoization, but for space complexity this will be order of n cross it 2. Why n cross it 2? Because you are using this tp table, and plus you will be using that stack space, right? So we can actually remove this stack space. How? If we use tabulation. So in tabulation what we'll be seeing, like this is a top down approach. and from tabulation we will use bottom up approach. So in what we will be doing, we will make the dp table first, and in dp table uh, we will fill the values with already solved problem with base cases, sorry. So what was the base case in recursive solution? If you reach to the last index, you cannot book any profit, uh, you cannot buy or sell something. So what we will do, like we will make the dp table for size n plus 1 cross it 2. Why n plus 1? Because the base case was if you are on last index, you cannot buy or sell. So the size of dp table will be n plus 1 cross it 2. And with the base case, with the base, like first of all you will be filling the base cases, and after that you will start the traversal from n minus 1 to 0, and the buy will be the same, like 0 to 1, right? So let's so in that the time complexity will be like same order of n cross it 2, but the space complexity, that will be only n cross it 2. That like in this we are not using this that stack space again, so that will be not in this case. So we are getting benefit in this space complexity. So I hope you have understood this. Let's see the code. So this is your memoization solution. Let's see this. So what I'm saying is, initially we will pass this function with like this is the zeroth index, then this is the buying listed, like because at the index 0 you can only buy. So what you are doing is, like if this is the base case. So if you are on the last index, you cannot book any profit. So return 0. And if you have solved already the problem, just return that. I don't need to solve it again. And if this is a time of buying or selling, check that first. If this is a time of buying, either I can buy, so minus price of index. Why minus price of index? Because at the time of buying you need to give the money, so money will be in negative. And then you are saying give next index, and I'm passing 0. Why 0? Because you have buy now, and now you will be selling. So selling we are indicating with 0 and buying with 1, so that's why I'm passing 0 here. And this is when you buy. Or I have the another possibility, I don't want to buy, so in that case go to next index with the same 1. Why 1? Because you will be buying on next index also, because you have not buy this time. Another possibility is what? This is the time of selling, so either you can sell. So when I will be selling this, so I will be getting this price of an index in the positive. And with this I will be subtracting the fee value, because I'm done with the one transaction, one buy plus one sell. So at the time of selling, that will be your transaction, a complete transaction. So subtract this fee. And like this is when you are selling. And if you don't want to sell, so in that case just go to next index with this same sell indication. This is a memoization solution. So let's see how the tabulation solution would look like. So first of all, make this dp table, and I'm initializing the values with 0. Why with 0? Because in the base case we have seen, when the index is the last one, so at a time you cannot book any profit, so that is 0. So that's why 0. And I'm making this dp of size n plus 1 by n plus 1, because I need to fill the value with base case, so that is n. So for considering n, I have to make it n plus 1. So what we have done before, like we are like we are we have uh, we have stored the value for n, right? We have stored the value for n, like this is the 1, this is 0. We have stored the value for n. And now I can check for values. Like I will go from right to left. Why right to left? Because like this is your base case. So with this I can solve this n minus 1 state. How? Because at like every time, like if you are at particular index, you need index plus 1, like the next values. So for get, like if you are every time you are utilizing the next values, so for that you have to go from right to left. So if you have solved this, like this is filled with base case, so when you are on this you can actually get help from next step and you can solve your problem. That is how. So just go from index n minus 1 to 0 and buys that again 1 to 0 and do the same thing, and in the last your answer will be stored at dpf 0 comma 1. So 0 is what, like the first day, like what you've done here, like 0 syntax and fun, and 1 is what, buying. So that same thing we are doing here also. So I hope you have understood this problem. If you have understood, please like this video, and if you have any doubt you can ask that in comments. And for those who are new to this channel, so I make video solutions for DSA problems, wherein I explain similar to this, like intuition and approaches, time complexity, space complexity, and code as well. I explain. So you can subscribe if you like my explanations. Thank you.